let's find S when it's the inverse of f of t. Now, f of t is this guy here. And we need to find it at t is equal to 2. So let's have a look. So this is at t is equal to minus 2. Apologies. This one here. All right, so what's important about this one is that it's the inverse. So you can see it as s of t is equal to this 1 on f of t. Now, there's two ways of doing this. You can use the product rule and put the f of t at the top, like so. And you can do that, but it is a little bit tricky to do without seeing some numbers there. Or you can use the quotient rule. So this is where you say the top is 1 and the bottom is here. So the equation for our quotient rule is given by this here, where s prime of t is equal to the bottom times the top differentiated minus by now the top times by the bottom differentiated, and then the easy one to remember is the bottom differentiated squared. So we've kind of got our t's, right? We can say t is equal to 1 and t prime is equal to 0. So interestingly enough, that cancels out this one, and I'll put in the numbers later so you can see what's going on. But now we need to figure out what the bottom is. So we need to figure out what the bottom is, right, at minus 2, and that's f at minus 2. So let's have a look at the graph. So f is the left-handed one, and at minus 2, that is equal to positive 2. So if we go across, we can say definitely that is equal to positive 2. But now we need to find that differentiated. Okay, and differentiation is finding the gradient. So we have a look at the slope of this line from here to here. Okay, and when we choose a point, let's say this one, we run along one, but we drop by 1, 2, 3. So it's a line like, y is equal to mx plus c, where m is the rise of the run. So m is equal to our rise. In this case, that's equal to minus 3, and we have run along 1, so it's minus 3. That is this part of the equation. Now we just need to substitute everything in there. So when we do that, we get something that looks like this. So just the bottom one, normally, times by the differentiated one, so we can say that all is equal to 0, minus by the top, which is just 1, the bottom differentiated, which is minus 3, and the bottom squared, which is 2 squared. So that is equal to minus 1 times minus 3, which is 3 divided by 4. And that is our answer. So that is the gradient s prime at minus 2 is equal to 3 on 4.